Today we will be reviewing LRAM, RRAM, MRAM, and Trapezoid rule. By the end of this video, students will be able to use LRAM, RRAM, MRAM, and the Trapezoid rule to estimate the area of a curve by drawing both rectangles and trapezoids of set intervals.
Students will also be able to analytically use LRAM, RRAM, MRAM, and Trapezoid rule by using a chart. First, we will be practicing LRAM with this graph. We will be using bounds between A and B for 4 intervals. To find the area under this curve, we will use the left endpoint, which is f of A, as the height, and multiply it by the width, which is b minus a divided by 4, since we have 4 intervals. Continue to do this for fx of 1, fx of 2, and fx of 3 to find the area under the curve using left endpoints.
Just like in the last example, you will be finding the area under the curve, this time using RRAM. To do this, we will start from the right endpoint, which is f of b, as the height. Then multiply it by the width, which is again b minus a divided by 4. Next we will continue with the heights x of 3, x of 2, and x of 1 to find the area under the curve using right endpoints.
To start using MRAM, we must find the midpoint between each set of intervals. Once we find the midpoint between each interval, we will then plug that into the function to find the height of each of the 4 rectangles. This height again will be multiplied by the width, b minus a divided by 4.
Now we will use a chart to analytically find the distance a boat traveled. For this example, we will be using MRAM. Our width is 5 seconds for each interval, and this will be multiplied by the midpoint between each interval, which are 4.5, 11.5, 14.5, 16, 16, 18, and 16. And we should get a total of 482.5 meters. Now we are using the trapezoid rule to find the area of the curve of y equals f of x. To find the area of the trapezoid, it is 1/2 times the width times base 1 plus base 2. Take notice that x1 and x2 are the bases of 2 different trapezoids. Find the area of each of the 3 trapezoids and add that together, and you will have the area under the curve between the intervals A and B.
Last, we'll be using the trapezoid rule to find the distance traveled using this chart. For the formula of a trapezoid, 1/2 width times base 1 plus base 2, we can find the total distance. The width for this equation is 5 because each time interval is 5 seconds. Each one of the intervals will be involved in 2 trapezoids except the end numbers, which is why the rest are multiplied by 2. By following this formula, you should end with a total distance of 435 meters.